Hi everyone. Let's start the first model in the advanced control system, state variable analysis and design. Already I said in this first model we are going to see the first difference between the your previous conventional method, whatever I studied in the control system subject, and what is the state variable analysis technique. Difference between them, it is an important question. Sometimes they may ask advantage of state variable, or they may ask the difference between conventional and state variable analysis, and important definition, then state model by using the different methods. Okay, one question for this state model. Okay, you can use any one method. If they ask a particular name, method name, you go through that method and construct the state model. Construct the state model is nothing but construct A matrix, B matrix, C matrix and D matrix, right? See, in the conventional method, that is whatever you have studied in the control system subject, that is nothing but a conventional approach to study the behavior of the linear invariant control systems by using the time domain or frequency domain methods, right? In all these methods, the system are modeled using the transfer function approach. Okay, transfer function is nothing but ratio of output by input, output to the input ratio. So neglecting the all initial conditions here. So this conventional approach is fails. It is a fail to face the so many approaches limitations associated with the transfer function approaches, right? So first we have to see the some limitations of conventional methods, that is drawback of transfer function model, whatever you have studied in the control system subject. First drawback is transfer function is defined under the zero initial conditions. Compulsory it is a zero initial conditions. I think, I hope you remember this. Okay. Second is transfer function is applicable only to the linear time invariant systems. Okay. Next, it is restricted only to the single input and single output systems. Remember, only one input and one output. You have studied the transfer function. U of t is only one input, and for the block diagram also you have used only single input, single system. It is fails to analyze for the MIMO system, nothing but multiple input, multiple output system. Next, it does not provide any information regarding the internal state of the system. It gives the analysis of system for a specific types of the inputs like step, ramp, parabolic. Already you have studied, right? This is what only applicable for these inputs. And the conventional method is insufficient and trouble to give the complete time domain, and it is fails to give for the higher order systems. Okay, just tell me, only you used high two order system, right? S square or x square, x square plus x plus constant. Only two order system you have studied in the control system subject, but higher order, that is x cube, s raised to 5, s raised to 6, it is very difficult to find the stability analysis for the system. See, Bode plot, Nyquist plot, you have studied different methods, right? Only to second order system you use. Second order means power 2, s raised to power 2. For the higher order of the systems, it is very difficult to find the, it is very difficult to analyze the system. Okay. The classical methods like root, locus, Bode, these are all basic trial and error method. We can't give the exact result for the system. We can't say that the system is completely stable or completely unstable or marginally stable. These are the what Bode, Nyquist, all are trial and error methods. Just we are giving the comments. It is a stable, it is unstable, it is not 100%, it is not a final result for the system given, right? So these are the what drawbacks, whatever I studied in the control systems. These are the only applicable, these points are applicable for the conventional approach, but it is a drawback, it is a limitations only to the linear systems, zero initial conditions, only lower order it is applicable, only these type of the inputs it is applicable. Okay. So it is not giving any internal state of the system. So overcome to these drawbacks, we are going to study the state variable analysis techniques. Here, the state variable analysis technique we can apply to the different systems, linear systems or non-linear systems, time variant and also time varying systems. And it is also applicable for multiple inputs and multiple output systems. Okay. If they ask advantage of the state variable analysis, whatever you have discussed, right, drawback, reverse, you can write advantage for the state variable analysis. Okay, these are the drawbacks of the conventional methods. To overcome all these drawbacks, we are going to study the state variable analysis method. So it is very important question. They may ask advantages of the state variable analysis technique or drawbacks of the conventional method. So first advantage is reverse of those limitations. Okay, reverse of these means what? Here it is it is defined only under zero initial condition, right? And state variables, what happened? It is applicable for initial conditions other than zero initial condition. Second is drawback is what? Here it is applicable only in a real system. And state variable analysis, you can apply linear system, non-linear system, time varying, time invariant systems. And here drawback is only it is applicable single input and single output system, but state variable analysis we can apply for multiple input, multiple output, that is MIMO systems. That is advantage. Next, here it is only internal, it is not giving any internal structure, but state variable analysis it gives the total internal state of the system. Next, it gives it is only taking the input step ramp, right? But state variable analysis we can use any type of the inputs. We are getting the output with respect to the inputs. Next, this is a drawback here. It is applicable only to the lower order systems. It is fails to higher order, right? But state variable analysis we can apply for higher order systems also. And in the conventional method, it is a trial and error method, right? But state variable analysis, it gives the correct exact result for the system, it is stable or not, right? So exact reverse of those advantages of the state variable analysis listed here. Convenient tool for the MIMO system. Okay, it is applicable for time invariant system, time varying system, linear system as well as non-linear system. Okay, here we can apply almost all type of these systems. It can be performed with initial conditions. Next, variables used to represent system can be any type of the variables. Variables are nothing but, don't confuse, state variables are nothing but you are using voltage, current in your system, right? Voltage is a one variable, current is a second variable, input is a one variable, output is a next variable. These are the what we are giving the name. Current is first variable, voltage is second variable, input is third variable, output is fourth variable. These are the what our variables. So here we can use any type of the variables. Next advantage is internal state of the system we can predict by using this method, and as the method involves matrix algebra, so it is conveniently adapted for the digital computers. In control system, we are not yet using the computers, computer techniques, but in state variable analysis we are using matrix algebra. Hence, it is applicable, it is adopted for the digital computers also. Okay. See, they may ask advantages or drawbacks of conventional method and comparison between them. Those whatever you have discussed now, those are listed here. Comparison. Okay, go through this comparison.